People always think we're attacking NASA, and we're actually NASA enthusiasts when it comes right down to it, right? We're space enthusiasts. We want accountability. We want disclosure. We want to see what's actually there, and we will accept the limitation. We'll support the limitations on what's capable of doing. We don't need to keep researching in and find out, oh, all we're looking at is CGI. If you can't do it, say so. I was looking at NASA's inventions, things that they have invented. Apparently in the late 70s, early 80s, they developed a implantable defibrillator for people. That's one thing that they did, which has got nothing to do with flying anywhere. They came up with a material called temper foam, which is like memory foam, and it's for use in motorcycle helmets, military helmets, that kind of stuff. It remains soft until it has impact, and then it has the absorption, the high absorption structure, right? The other invention that they had was a breathing apparatus for firefighters, which they improved the mask, and they moved the balance of weight down by putting a harness around the hip to hold the weight instead of it being up on the shoulders. Nothing to do with the length of time or how much air that you can run walking around on the moon. They should have had all those little bottles that go for 8 hours, right?
8 hours at least.
Their other invention that they have claimed to fame over is an orbital simulation software.
That sounds as if they're cheating a bit, doesn't it?
Yeah, so it sounds like they like to do a lot of simulations when they spend that kind of time and money to develop the software for it. But I didn't see anything dramatic on these space materials that they have to keep working on and testing, right? Never saw anything. When you Google it, you don't come up with anything like that. I do know that in the early 2000s that they came up with a much better aluminum material. Much harder, has a better transfer of heat and stuff like that. And it was actually used by BRP for Evinrude outboards for their engines. And this enhanced aluminum that they made, they didn't need to use a cylinder liner, like they didn't have to have a metal sleeve liner in the pistons, like in the cylinders, right? And that aluminum is able to transfer the heat away. And of course, they came up with a special oil lubricant to go along with it at the same time that they used in Evinrude outboards. I think 2004 or something like that, they came out with it like that. And of course, Evinrude outboards is now out of business. That was the only material invention that I ever saw, was just this higher performance aluminum that they had.
We were looking at this Apollo again. We were looking at the PLSS, and we're trying to understand how they could get out of that little bottle of oxygen in there 8 hours worth of breathable oxygen throughout that suit. Now, we did a load calculation yesterday, and this is quite interesting, and this is going off of NASA's own loads and battery life and wattage and watt hours.
Yeah.
But what happened, right, was when we did the calculation, I calculated that it could only last 5.26 hours, the battery life, with all the pumps going, relays going at 40% duty cycle. Then, of course, then you also have that heater up in the top, which is on a separate 27-volt battery. But the communications are actually running off of the battery in the PLSS. So you can add that to it. So every time they key that microphone, not only are all the motors and pumps going, but also the transmitter is transmitting when they key the microphone up. So now what you have to do is you have to say to yourself, how long is that battery going to last now? Never mind the oxygen in that tiny little tank.
And by the way, Robert was taking the calculations from the latest PDF files, where the battery is very much improved from the previous PDF files.
Well, that's useful, isn't it? Nice that they improve it.
There are probably, at least 5 different versions of this battery?
Yeah, because one said it was 12 volts, one said it was 16 volts, the other said it was 16.8 volts, and then the other one said 20. But when I went to this PDF that was supposed to be original, it said 16.8. So that's where I did the calculations off of the 16.8.
Yeah, that's fair enough. 0.8 was the original figure. That's what you should work with.
Yes, and I came out to 5.26 hours worth of battery lifetime on that. And I didn't add the radio into it because I thought the radio worked off of a separate battery in the pack on the OPS unit where the transmitter is. But according to this PDF, the transmitter is actually working off of that battery, that 396 watt battery that's in that PLSS pack. You're only going to get 5.26 hours out of it, and I haven't added the transmitter yet.
Which would take quite a lot of power if you're going to do it properly.
And the other thing is all those calculations are at 40% duty cycle.
Oh, that's for the relays opening and closing, right? Just because they're not going to be energized all the time. So I gave it a 40% duty cycle, and then I came out to 5.26 hours worth of voltage in that battery. But I didn't add the transmitter. So now you're going to have to ask yourself, now how long is that thing going to be out there? Because I've taken a 12-volt alarm battery that had 4 amp hours worth of power in it. I put it on my CB radio, and I only got 15 minutes.
Yeah.
That's it. And that's transmitting. You know, we're transmitting here. 15 minutes on that battery. And now we're running relays and pumps and fans and radios.
Well, that's going to reduce it a bit as well, isn't it?
Oh, the water pump's going to take it down dramatically because it's a continuous run.
Yeah, because they've got to circulate the water through all the pipes inside the suits they're wearing to remove the heat.
Of course, the newer documents claim all the batteries are rechargeable, of course, and they're still giving the contents as a zinc acid battery, which is a non-rechargeable battery. And then there was one document that said that they added cadmium so that it's now rechargeable. Cadmium zinc acid battery, right? So that's so-called rechargeable. But that actually wasn't invented before, 1980, 1981 when we looked it up. So when you see these documents, when you see a PDF file, of course, the first thing I recognize is they've put color. Like they have nice colored plates in the PDF file. You know it's an updated document because the originals aren't. Right?
Black and white.
The originals are just quick scans that they put together of the original documents, right? So when you see the color added in there, you know everything's been modified on it. So we were just looking at the different stuff for the batteries, for the PLSS, and stuff like that.
And then you look at the scuba tanks, and we were talking about Jacques Cousteau. Look, he had 2 scuba tanks that he took down with him. 1 for the air to get down there, and 2 for the air when he decompressed.
But he only had 45 minutes total anyway.
Yes, well, how is NASA getting 8 hours out of that tank without recharging it, and the tank is 6 times as small as those 2 tanks put together?
NASA does their calculations for their oxygen by a factor of 10. Their lift capability is a factor of at least 5 on what they're capable of lifting. If you take a look at any rocket engines today, at most, they're only 20% of an F1 engine. Just 20%, that's all they're capable of lifting on that, and they're using the same fuel. And if they build them that small, it's because when you get up past that 200,000 pounds of thrust, you get that vibration running through there. That cycling is attacking all of the equipment and taking it apart, right? You get that 180,000 cycles per second ripping through the equipment. I mean, when you go above that, you're just going to enhance that. And even yet, they still have to use the water on the launch pad to dampen that. Apollo had the same problem, but were those engines any more powerful than what we see today? Probably not. The thrust capabilities, multiply it by a factor of 5, and then that becomes NASA, right? The same as with their height calculations, their testing stuff. Just multiply it by a factor of 5, or reduce it by that much based on what NASA says. Instead of 300 miles, they do it by a factor of 5, and you're at 60 miles, right? now we're getting closer to reality.
Well, it's been reality right from the beginning, because no other rocket since the Saturn V has had an engine that can produce that level of thrust, 1.5 million pounds of thrust. Now, I mean, this is why Elon Musk is producing a rocket similar to the Soviet N-1 rocket, which had 30-odd engines, 30-plus engines, just to produce that same level of thrust. If Elon Musk is producing a similar type of rocket with his super heavy lift, the Starship rocket, 30 engines, I mean, getting them all to fire correctly is going to be quite a problem. Maybe they can do it better now. But no other rocket engine can produce that level of thrust today. He was doing it 60-odd years ago with the F1 engine. So what's happened? Has technology gone backwards again?
And it's only lifting half the amount that NASA claimed.
Yeah, exactly.
32 engines on that. 16 are solidly mounted and the other ones are articulated.
That's right, yeah. I was reading through a few of the comments on the Shill Stompers, and I thought, I don't want to go on with this. It's just tedious and boring. Was it Cleric 58? He keeps posting. I don't know how many times I've seen it. His description of what I was alleged to have said at the British Interplanetary meeting 10 years ago. He's still posting it as if that's some sort of gotcha. It's not. He hasn't talked to me about it because he won't. But he claims that it's a final nail in the coffin.
Oh, well, he took your words out of context every time he comes up with that. And you were sitting in a situation where you had to be complicit to some degree just to be invited there.
Yeah, exactly. I mean, it was fairly obvious. If you looked at the film and you looked at how I conducted myself when I was talking to them, I was being polite. I'm British, for God's sake.
Yes, you're British. You have a politeness built in from birth. Something that is not acquired by any other nation in the world. It's quite unique, actually.
It is quite unique. There are advantages to it and there are disadvantages to it. And maybe I carry both of them. I find it really interesting that is the only thing they can come up with, as if that is a definitive proof that what we're saying is nonsense. It's not. As you say, look at the context of what was happening when I said what I did. It makes sense. Yeah, I was being polite. I was accepting their position as being advocates for NASA and advocates for space travel, which we all are. If you looked at the pictures I showed in the presentation I gave, I think it's fairly obvious that I was not as impressed as whoever this chap is considers. So he posts all this stuff on there, and all his mates pile in and agree with him. And after a while you think, just like you said, Robert, I don't want to read this stuff. It makes no sense. It doesn't help anybody. It's not contributing to the discussion. It's just their sort of regurgitation and outpouring of bile and unpleasantness personified. It's sad that they still have to do it, and they've been doing it for about 10 years as well.
And I see you want to get on there with mumbling.
Yeah, that's got to be fun.
Yeah, well, unfortunately, the man, all he can do is disagree. Run around in the Australian desert, he doesn't have anything, and he just goes, well, I believe it's like this, so anything you have to say doesn't count, right? He's at the same level as the blue thingy guy.
I think he looked through his telescope and realized that no matter how hard he looks, he will never see those landing sites, even if he could. And that's because they don't exist.
But if you use Photoshop, you can create them out of nothing, which a lot of people have done.
Look at what that guy did with this iPhone. Zoomed into the footprints on the moon. I mean, it just take a couple of images and have them pull forward on there. Robert and I were looking at some of the latest rovers that they're going to have for the moon. None of them are manned. They got a little three-wheel one that runs around in circles, I guess, and a little four-wheel one, right? That's all they've got. They tried to make the four-wheel one look like the Apollo rover a little bit, but there's no seats in it. Those are not for manned missions. Those are for unmanned missions, these rovers.
Yeah.
And that's the point.
I still say that nothing's going to happen until at least 2030 or 2035 because it's going to take them that long to put that gateway station together.
I mean, they haven't even got a lander yet. They got 3 contracts for people who are supposed to do it. Dynetics, SpaceX, and Blue Origin are supposed to have landers. But they're not ready yet. They haven't been tested, for goodness sake, let alone gone into space. Don't forget, 50 years ago, Boeing managed to build a lunar rover, 3 of them, we're told, which are still on the moon. And if you want to go and look at them through your telescope, well, you can go and find out what they were made of. But they didn't work either. They couldn't work because they were lead-acid batteries, which would have, in the vacuum of space on the moon, the electrolyte would have vanished. So they weren't producing any electricity, but they still persuaded us that they had done so. It's so pathetic. Now the whole thing is unraveling because people are trying to do it again, and we're finding out that what Apollo did was faked, fiction, fabrication. The whole thing was just not working. But it had to work to fulfill the dead president Kennedy's ambition. And there's a lot of question marks now about who was responsible for killing Kennedy. And it's all coming back to the same people, the clowns in America. It's becoming actually quite difficult for the authorities now to maintain their position. And they're not. They're moving away from it, which is probably why they've given the whole human space activity to the private sector. NASA are not doing it because they daren't do it. They're letting other people fail where they claim to have succeeded.
And they're not failing in the money market.
Oh, no. Money's good stuff.
The private companies are going to keep doing it because they're being sponsored by an awful lot of people, and other corporations want to get in there and be part of that as well. Everybody needs to get a piece of that change that's being thrown around there, right?
Yes, they can see the money and where it's coming from, and they want part of it. That's what private companies do. They take advantage of a situation. It's becoming so obvious now. NASA have got a real problem ahead of them. How to maintain any form of credibility. When A, they've lost a large number of staff to the private companies, and B, they haven't got the technology. They're trying to look at the technology they did have and found it didn't work. They've got a real problem, a credibility problem.
It's not the technology itself, it's the materials that they don't have to work with. And of course, one of the biggest downfalls, of course, we're back to the engines. I mean, to get the amount of thrust they need, the fuel weight alone to even get into low Earth orbit, the concessions you have to make when you're at 1,000-to-1 payload capabilities for the amount of machinery that you have to have, right? You're not going to go very far. If you build the rocket bigger, then your actual payload goes down. You eventually get to the point where your payload becomes zero because the amount of fuel you have to carry to do the weight calculations for the entire rocket, you can actually get to zero. So it won't even lift off because you're holding that much fuel. You would sit there and burn on the launch pad until the fuel comes down, then it starts to take off, right? And I mean, what was Apollo? 20 tons per second, 4 tons per engine of fuel per second taking off. 2.5 minutes, it burned 6 million tons of fuel. It's just incredible. That kind of consumption there, that weight penalty you have because of the type of fuel that you're using to fire that rocket, just isn't going to allow us to travel anywhere.
No, it isn't. Somebody's going to have to come up with a much more progressive means of launching into space.
One of the main points about reading the PDF files is anything you see in the conclusions showing the problems that need to be researched or further research or whatever in there,
yep.
You will not find a PDF file that claims that did testing that solved those problems.
No, and then the laser reflectors, I like sarcastic. He said, fun fact, NASA quit using the reflectors 20 years ago and now uses the LRO. It has reflectors the size of an iPhone on it. Supposedly, that's what they use now. How can a laser zero on something that small? Is it smaller than the reflector or the same size?
Well, that LRO is orbiting the moon at 6,000 miles an hour.
So what's it bouncing off of? Nothing. Just the surface.
Yeah, just the surface, like all lasers will do. The British were bouncing radio waves off the moon in 1946. So what's different with laser? It's just a higher frequency. But of course, the point that you made, Scott, is that over the last 50 or so years, there's been a gradual rain of interstellar dust. Now, don't you think that might have an effect on the reflectivity of mirrors? Probably.
It's the photoelectric charge that levitates it every month.
There you go.
and sets it back down. There wouldn't be a bare rock anywhere.
No, there won't be. That's why the photographs of the lunar surface that the Chinese have returned shows rocks sort of sticking up out of the surface, whereas the Apollo photographs don't show that.
You look at the moon with a telescope, you can see just the edge of the old craters, and it's all filled in, completely filled in. You just see the edge, and that's hundreds of feet deep. And of course, the Sea of Tranquility is the least active part as far as micrometeors or any meteor activity, right? So whatever has been pulled up from micrometeor hits kind of roll around the surface and land there. That's a perfectly smooth plane. Why would you want to land there? That dust is so fine and so light. It could be hundreds of feet deep.
In the photographs, it looked flat. It looked featureless.
Well, you see that in a telescope, right? You can see the different things. But when you realize that the craters, when you're looking around the edge, the ones that are filled right in, just the outline of the old crater. The young micrometeor hits, you could still see the radial striations coming off from the impact. But then even that disappears with the dust.
Of course it does.
Look at what Shakespeare HD said. Now, here's another guy that's interesting. He says, I'd suggest to look at the issue of being in vacuum. I have seen vacuum chambers used at the university when I was getting my degree, and they were not made of aluminum sheet metal like the LEM. They were small compared to the LEM, yet massive as can be. Then there is the issue of seals needed for the door in extreme vacuum. This one simply blows away the myth of being on a dusty moon and exiting through the door multiple times, yet not having a seal problem. I don't buy this, period. In one of the transmissions, it was even stated that the dust was floating all over the cabin.
Exactly. And if you've taken your helmet off and the dust is still swirling around inside the cabin, inside the lunar module, you're going to breathe it in. And that's not going to do your lungs much good, is it?
Oh, it's absolutely deadly. That's one of the things, if you're reading any articles on Chernobyl, they're still wearing masks, rebreathers and stuff on there. If you get some dust on your skin, it's going to absorb in. But you can wash the dust off, and it'll stop the absorption of the radiation. If you breathe it in, it's internally in your body and stays there, and it will eventually kill you. It makes it absolutely deadly. And of course, if you look at the photographs from Apollo 17 with Cernan, after their first EVA, and his whole face is all covered in dust, it's in his hair and everything else. And then on the way back, he just got it right out of the salon. You can see his hair has been, it's got hairspray in it, it's got everything. I mean, it's freshly shaved.
Yeah, I mean, you've got to look good for the TV cameras when you come back from this big voyage out to the moon and back. You're a hero. Heroes have to look smart, clean-shaven, no bruised fingers, which is what Cernan claimed to have had.
They all claim to have had abrasions on their hands from wearing the gloves. So how long were they actually wearing the gloves when they were in those suits, doing those simulations?
Basically, they weren't on the moon at all. They couldn't get there. They never have been able to get there. They still can't get there. But Apollo tried to persuade us that they had got to the moon. And it's just so much rubbish because they can't even do it now. Over 50 years later, they can't repeat it. If they could repeat it, it's the point I make about exploration on Earth, which is similar given the technology we've got in the 20th century. Technology we had in the early 15th century, 16th century, when Christopher Columbus discovered America. Well, he didn't discover it because there were people there already, but he was the first European to get there that we know of. 30 years after he got there, Spain had sent its forces over and occupied Central America and subsequently South America. That's what exploration is about. When Captain James Cook from Britain, from the UK, discovered Australia, the Dutch had been there before, but he was the one with the bigger guns, so he was the one who took charge. 1770, within 30 years, Britain was shipping its prison population out there. That's what exploration is about. 1969, man lands on the moon. 50 years later, nothing. Nobody's been back.
When you come down to it, they don't have anything that's capable of lifting the weight they need to lift.
I mean, they say they've got the Artemis program, the SLS rocket, the slow, late, and expensive rocket, or the Space Launch System, as it's better known. But so what? That's just an upgraded version of the space shuttle. Big orange tank, fuel tank, 2 solid fuel boosters on the side. It's not a new rocket. Elon Musk has produced a new rocket, a Starship, using methane, and he's using what he refers to as the Raptor engine, which is quite good. Seems to work quite well. And Jeff Bezos is doing the same thing with Blue Origin. But they're all private companies, and they have to start from scratch. They don't have the knowledge that NASA claimed to have, but they didn't have because they hadn't been to the moon.
I think one of the biggest things that's happening right now is the increased activity of solar flares over the next number of years is going to put a damper on anything, like even if they could do it now. But even for unmanned craft, because those solar flares simply are going to be taking those machines and just cooking them. You look at all the balloon activity now.
Yes.
I mean, what's wrong with their satellites? Why are they back to balloons? I think that solar flare that happened in November was fairly severe. I would imagine the few operational satellites that were up there were probably destroyed. Now they're using balloons because every week there are solar flares right now. There was one just on the 10th, and it has this, it's coming up and swirling. They claim a piece of the sun at the North Pole broke off or something and created this huge thing. Not that the effect of that is not actually pointing at us. I mean, that's when we have a serious problem, when you have a solar flare that's actually pointing directly at us. When they claim they put Artemis up there, I mean, there was 3 in a row hit it directly, and all of a sudden we're back to using balloons.
Balloons aren't affected in the same way, are they?
Well, they're running one of them they picked off at 40,000 feet. Another one was about 70,000 feet. The one that they didn't say how high, the one that was just next to here. Yeah. It was just out on Lake Huron, right? That's 5 minutes airtime away from here.
Yeah, but NASA's sure taking their sweet time at putting out the radiation values from Artemis.
Well, they're not going to. They're not going to release any of the documentation on that.
And you would think, by the way, the solar flare that happened, now you would think that their equipment would have picked that up.
Yeah, but if they haven't released the data, I wonder why they haven't released the data. Could it be because it doesn't agree with Apollo?
I don't know the answer to that, Marcus, but I can tell you that there's a lot of people in the comments section asking that same question.
Good.
And then how can you trust somebody that is not trustworthy in releasing the information? When you go back to Van Allen, he put radiation detectors up there. I don't know what they were originally calibrated for, but the radiation was far too intense that they had to do a lot of work just to be able to read it.
The first Geiger counters he sent up on Explorer 1 were overwhelmed, so they had to recalibrate it and put them up at a far higher level. Despite what people say, remember Peter Bassett's comment about those radiation meters? He was trying to excuse NASA's behavior and failed, which is a normal situation. So on Explorer 4, they put more Geiger counters on, but calibrated to much higher levels of radiation, because that's what they found. If you get an overwhelmed Geiger counter, you've got a very high level of radiation.
So if you shield it and then read the numbers, then those aren't the real numbers. That's the numbers after it's been shielded. So if you release that, that's still not accurate. If the numbers are so high you can't read it, there's definitely a problem. You know, I was sitting thinking, because we've done so much on film and cameras and everything else, and it suddenly struck me. If you're going to modify a camera to work in a particular environment, well, first of all, they missed the fact that they needed to pressurize the entire unit to keep the film done. Would you not also want to have a dosimeter on that camera?
Yes, you would.
Would you not also want to have a temperature gauge on that? Because you're going into an environment that is swinging 500 degrees. Yeah. And you'd want to be operating that camera and go, oh, look, the temperature's going up. We better do something about it, right? Put it in the shade, cool it back down. It didn't have either one of those gauges on there to operate that equipment.
Yeah, because that would have given the game away, wouldn't it? So they couldn't have them on.
You'd think if it wasn't on the camera, they would have at least that on their sleeve. You know, they had the cue cards and the watch because they needed those two items to complete the storyboard because it was already printed in the cue cards how long it's going to take to get from one station to the other when they set them all up at Flagstaff, right?
But the metal's not going to heat up. That's what they're going to say. Because there's no atmosphere, you can't have any convection. But there's still radiation, so the sun's rays are still hitting that camera.
Well, you're not trying to read the atmosphere because there is no atmosphere. You're trying to read the case of the camera.
Yeah, so you should have a thermometer or something like that on the camera. I remember they had stickers that you could put on things back then, and they would change color depending on what the temperature was. I mean, they could have had something like that, too. You know, and another thing, too, that's interesting is what that one NASA astronaut, remember we were looking at that, and he was saying that when they took pictures of the rock samples on the moon, didn't he say that when they got back or something that
he said they had to shield the camera or shoot the rock samples at a particular angle to avoid the radiation coming off the rocks, off the samples. So that's documented.
So then why, when they get all these rocks back, there's no radiation readings on them if this guy's so worried about it? It's just like Neil Armstrong opens up that rock sample case and it's still in a vacuum.
You wouldn't be able to open the case if it actually sealed with a vacuum. You'd have to drill a hole in it to let the pressure off.
Of course you would.
You'd never open it up even if there was 1 pound of difference. You couldn't open a door if there's only 1 pound of difference. Just based on the square footage on there, you're looking at well over a ton of force that you'd have to apply. Just on a small differential of air pressure, you wouldn't be able to open.
Because these are things that NASA rather overlooked when they created their fiction about landing men on the moon. They forgot some of these details. And we can now identify the details and ask the question. That's all we do. We ask the question, how was it possible to open the rock sample box that had been sealed on the moon, in the vacuum of the moon? How was it possible to open it on Earth unless you drilled a hole in it to let air in, to reduce the pressure, or to equalize the pressure? It's a perfectly legitimate question to ask. So where is the hole in the rock box?
There's no valve control to open anything to allow that. And how would this very thin aluminum case not just collapse?
Well, of course it would.
And of course, that would happen as soon as they repressurized the lung. And it would be rather upsetting to be in a very small confined space when that thing goes off.
Definitely.
Don't forget, they were in a spacecraft in a confined space with dust floating around all over them, right? Dust on their faces and rock samples that were highly irradiated over hundreds of millions of years of continuous radiation impact. I mean, even if you've got a half-life of 1,000 years, you're going to have 2,000 years of radiation absorption into the rocks. And it doesn't matter how many more times the radiation is hitting there than it is from Earth. It's the absorption rate continuously there. Then you have the CMEs that are just going to fully impact those things and jump that radiation. And during that time period, we were at a high level of solar flares. It was reaching a peak close to, Apollo 16 in that range, right? So these samples that they brought back would be at even a higher level. They handled them with their bare hands. The return of the spacecraft, I mean, they handle it with their bare hands. They pull it out of the ocean, and these guys got their hands on this thing that has been through the Van Allen belts twice and spent a dozen days in space.
I mean, we assume it's been through the Van Allen belts. We assume they came from the moon because that's what NASA say they did. It doesn't mean to say it actually happened, because they can't prove it. They cannot prove that they landed humans on the lunar surface who collected these rock samples, packed them into the boxes and brought them back to Earth. They can't prove that. They can say it, but saying it is not the same as proving it. Proving it. Proving it. Proving it.